right, so in this section, we want to talk about two different types of formulas, the product to sum formulas in trigonometry, and then after this we're going to talk about sum to product. Now what you'll notice is all four of these equations start out with a product. You know, product means two things multiplied together, okay? And we're turning it into a sum or a difference. And occasionally you have to do this in mathematics, specifically in a calculus class. You want to take a product, say sine of alpha, sine of beta. Notice two different trig functions, two different angles in your trig function here, and turn it into what was multiplication is now subtraction of two separate trig functions. Okay, so cosine of alpha, cosine of beta is again a product, because you're multiplying trig functions together of two different angles, and it turns into the sum of cosine. You take again a product, sine of alpha times the cosine of beta, that turns into the sum of sine of alpha, sine of beta, okay, or sine of two different angles, let me say it that way. So we're turning products into addition or subtraction. So to verify, we're not going to verify all four of them, they're very similar, but to verify the first identity, what I'm going to do is start with the more complicated side. So I'm going to start with the right hand side. I'm going to rewrite it 1/2, and we have cosine of alpha minus beta minus the cosine of alpha plus beta. And remember, whenever you verify an identity, it helps to start with the more complicated side, and you do work to this until it matches the other side, and then you have proven it's true. You want to explain each line of work. What I'm going to do first is use the sum difference formulas on cosine of alpha minus beta, and then again on cosine of alpha plus beta. So I have the 1/2 is going to remain in front for now. The cosine of alpha minus beta is the cosine of alpha, the cosine of beta, plus the sine of alpha, sine of beta. So that is just cosine of alpha minus beta. And then minus, okay, and now I'm doing cosine of alpha plus beta, which is cosine of alpha, cosine of beta. Now next would be minus, but this minus distributes in after this is expanded. So over here, what again would be minus is going to make that a plus, sine of alpha, sine of beta. Okay, and we use the sum difference formulas that we learned in 2 sections ago. All right, now let's continue the simplification process. Okay, and we use sum difference and we use the distributive property also. So we use the distributive property right here. Now I'm going to combine like terms if possible. I do see something important. I've got a cosine of alpha, cosine of beta, and a minus cosine of alpha times cosine of beta. So those cancel each other out. On the other hand, the sine of alpha, sine of beta, I have another plus sine of alpha, sine of beta, which is going to give me 2 sine of alpha, sine of beta. Okay, and all we did there was combine like terms. Okay, the next step, I got half of 2, which is just 1, so my final answer is sine of alpha, sine of beta. And look, that's exactly what we were trying to prove. Okay, so that last step there is I just multiplied 1/2 times 2, and there we are. So we got the right hand side to match the left hand side, and I promise you, if you work with the right hand side of any of these, you will easily come up with the left hand side, simply verifying an identity. Now use the appropriate formula to express each product as a sum or a difference. So here I go. I have a product because I'm multiplying the sine of 4x times the cosine of 3x, and they want us to write this as a sum or a difference. So I need the formula. You will have these formulas available to you on the test, the back page of the formula sheet that I've given you. And I want to make sure I grab the right formula. So pay attention. We did sine times cosine. So I'm going to go back and look for my sine times the cosine formula. I'm going to highlight it for you. So sine times cosine is our third formula. So notice we have 1/2 sine of alpha plus beta plus sine of alpha minus beta. Okay, So 1/2 sine of alpha plus beta plus sine of alpha minus beta. Now, you know, most of the battle is copying down the right formula, so let's check it one more time. So highlighted 1/2 sine of alpha plus beta plus the sine of alpha minus beta, and that's what I have. Now I'm just going to substitute in. So this is equal to 1/2 sine, and alpha is my first value, 4x, beta is 3x, plus the sine of alpha, which is 4x, minus beta, which is 3x. I do need to simplify this as much as possible, so that's 1/2. This is the sine of 7x plus the sine of x. Okay, and again, that's a 7x. It almost looks like a 2 I've got written in there, but that is just a 7. There we go. That looks a little more like a 7. Now, you can't add these together, you know that, right, to get sine of 8x. It doesn't work that way. You cannot add trig functions in that way. So this is really, to me, the best way to leave the answer. If you wanted to, you could distribute the 1/2 inside and say 1/2 sine of 7x plus 1/2 sine of x, but I don't think that's any better than what we've got right there. So let's try another problem. Okay, so I have cosine of 3x over 2 times cosine of 7x over 2. Well, again, I need to know that formula. So let's go back to our formula page. Okay, I'm going to highlight this guy in pink. So it was cosine, cosine, which is what we have here. And notice for the cosine, cosine, it's 1/2, it's still in front. And then cosine of alpha minus beta plus cosine of alpha plus beta. Okay, so 1/2 cosine of alpha minus beta plus cosine of alpha plus beta. So 1/2 cosine of alpha minus beta plus the cosine of alpha plus beta. Okay, again, let's check one more time. It's highlighted in purple. I'm doing a cosine cosine problem. So 1/2 cosine of alpha minus beta plus cosine of alpha plus beta. I believe we've got it written correctly. Now we just simplify by plugging in our alpha and beta. So my alpha is 3x over 2, my beta is 7x over 2. So I've got 1/2 cosine of 3x over 2 minus 7x over 2 plus the cosine of 3x over 2 plus 7x over 2. Simplifying that's 1/2. That's the cosine. 3x minus 7x is negative 4x over 2. Plus the cosine, 3x plus 7x is 10x over 2. You are required to simplify these expressions as far as you can go. So negative 4x over 2 is cosine of negative 2x plus cosine of 10x over 2 is cosine of 5x. Okay. One more thing we can do, we know cosine of negative, because cosine is even, is positive, so this is equivalent to 1/2. And that's going to be the cosine of 2x plus the cosine of 5x. And that's as good as we can get. Okay, so that is our final result. 1/2 cosine of 2x plus cosine of 5x. So make sure you understand what happened to the negative. Okay, because cosine is even, the negatives just disappear. And there's our final result. Alright, so now we have some sum to product formulas. So we're doing just the opposite. We're taking addition and or subtraction and turning that into multiplication. So sometimes that's what you need. You need to add two different sine functions. You don't want it that way. You'd rather have it as the multiplication of two sine functions. Okay, so we want to prove at least one of these, and all of them have the same type of explanation to get the proof, but we're going to start with the more complicated side, which appears to be the right-hand side. So we're going to say the right-hand side is equal to 2 times the sine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. Now what we're going to do is we're going to use our other formulas, our product to sum formulas that we just learned, and I'm looking at the sine cosine formula. So I'm going to go back to that page and look at the sine cosine formula, okay, and that's the highlighted green one we have here. Notice it's 1/2 sine of them added together plus sine of them subtracted. Okay, so 1/2 sine of them added plus sine of them subtracted. Okay, so here we go. It's going to be 1/2. Oh, actually, let me write that 2 down first because you notice it's still there. So right here, okay. Let's try this again. So that's equivalent to 2. And then now on my formula, 1/2, okay, sine of them added. So alpha plus beta over 2 plus alpha minus beta over 2 plus the sine of them subtracted. So it's going to be the sine of alpha plus beta over 2 minus alpha minus beta over 2. Okay, so are we sure about this? Let's check again. Okay, so let's go back and look. Sine times cosine is 1/2 the sine of the two angles added plus the sine of the two angles subtracted. And so we got sine times cosine, and that is the 2 comes down, then 1/2 sine of the angles added plus sine of the two angles subtracted. Okay, now let's simplify. Okay, by the way, this is the product to sum formula that we used. Now, this 2 times 1/2, that handles that. That means it's gone. Okay, now I've got sine of these two added together is going to be, they already have a common denominator, so I got alpha plus alpha is 2 alpha. The betas cancel. You've got 2 alpha over 2, which is going to be alpha, okay, plus the sine. Now, we're subtracting. So I got alpha minus alpha. Those cancel. And then, again, this is going to be the two negatives here, make a plus. Beta plus beta is 2 beta over 2. What we did is we really just combined like terms. So say some statement about like terms, and we have it. Okay, so now the 2's cancel. That gives me sine of alpha plus sine of beta. And all I did was multiply there, or multiply and cancel common factors. There's various ways to say that. And notice that equals to the left-hand side. So we're finished with this proof. And again, all 4 of those are handled in a very similar fashion. So now let's try to use one of these. So directions use the appropriate formula to express each sum or difference as a product. So they're giving us subtraction, so we're dealing with a difference, and they want us to rewrite this as something multiplied together. So again, let's reference our formulas. You will be given these formulas, okay? So our formula, now again, pay attention. You got sine minus sine. All right, so let's go back to our formula list and find sine minus sine. Notice that's the second one. Okay, and it says we're supposed to do 2 sine of subtract the 2 angles divided by 2 times cosine of add the 2 angles divided by 2. Okay, so 2 sine of alpha minus beta over 2 times cosine of alpha plus beta over 2. So 2 times the sine of alpha minus beta over 2 times the cosine of alpha plus beta over 2. This would be a lot easier if I had a formula sheet in front of me. There we go. Alright, so let's plug in. So I've got 2 times the sine alpha minus beta. Now alpha first guy, beta the second guy. So 5x minus 3x over 2 times the cosine of, let's add them, 5x plus 3x over 2. So now I have 2 times the sine of, that's 2x over 2. I think everybody would be comfortable with me putting x times the cosine. 5x plus 3x is 8x over 2, or 4x. So what have we done? We have turned a difference into a product. So we are finished with this problem. Okay? So now I want to do the opposite, well not the opposite, but another problem where I'm taking two separate cosine functions with two different angles inside, and then we're subtracting. We need to look up the formula for cosine minus cosine. So I'm going to go back to my formula sheet and find cosine minus cosine. There it is at the bottom. Notice that formula has a negative 2. Be careful, negative 2. Sine of add them together, divide by 2. Sine of subtract them, divide by 2. Okay, so again, cosine of alpha minus cosine of beta is negative 2. Sine of alpha plus beta over 2. Sine of alpha minus beta over 2. So negative 2 sine of alpha plus beta over 2 times sine of alpha minus beta over 2. That's the hardest part, y'all. So got negative 2 sine alpha is 15 degrees plus beta is 45 degrees over 2 times sine of alpha is 15 degrees minus beta is 45 degrees over 2. So that's negative 2 sine of 15 plus 45 is 60, divided by 2 is 30 degrees, times sine of 15 minus 45 is negative 30 over 2. We can do that without me writing that down. Negative 30 divided by 2 is negative 15 degrees. Now we could actually evaluate it. Negative 2, the sine of 30 degrees is 1/2. But we don't know the sine of negative 15 degrees. So actually, I don't think we need to take it any further than here. Okay, because it says, use the appropriate formula to express each sum or difference as a product. We express this as a product. We don't need to take it any further. And again, I don't know the answer to this. Negative 15 minus 45 is negative 30, but then when I divide it by 2, it's a value not on the unit circle. So I don't have to take this any further. Okay? To make sure I follow my own directions. Okay, so for this problem, I'm supposed to verify the identity. So remember the rules here are start with one side of the equation and use trig identities and properties of algebra to simplify and get the other side of the equation. So what I think I want to do is start with the left-hand side of this equation because it definitely looks more complicated. So I have the left-hand side equals, got cosine of 4x minus cosine of 2x divided by sine of 2x minus sine of 4x. And they tell me that equals something very simple. As it stands right now, not a thing cancels. So what I probably need to do, because I am in the section with product to sum and sum to products, is how about let's use a sum, or this is a difference in this case for both of these, to product and see if that takes us where we need to go. Remember the very last guideline in verify identities is to try something. So that's all I'm doing. I'm just trying something. So I need to go back to those formulas. I cannot remember them at all. Again, if you have your formula sheet in front of you, you're probably going to fare better than me. But I'm going to look up cosine minus cosine. Okay, so cosine minus cosine is this guy at the bottom. I got negative 2, sine of them added together divided by 2, then sine of them subtracted divided by 2. Okay, so this is equivalent to negative 2 sine of them added together, 4x plus 2x divided by 2, times the sine of them subtracted, 4x minus 2x divided by 2. That's just the numerator. And again, this is a sum to product that I'm doing right here. I'm going to do the same thing in the numerator, but with the appropriate formula. So I'm doing a sine minus a sine. So I'm going to look up the formula for sine minus sine, and actually it's the highlighted pink one. It's positive 2, sine of them subtracted, divided by 2, cosine of them added, divided by 2. Okay, so sine of them subtracted, cosine of them added with a 2 in front. So 2 sine of them subtracted, 4x minus 2x divided by 2, cosine of them added, 4x plus 2x divided by 2. And this is sum to product again. Now let's simplify. Okay, I'm noticing I've got a negative 2 and a positive 2. That leaves a negative. Okay, that has me a little concerned because there's not a negative on the right hand side, but that's okay. We may figure out what turns that back positive. The 2's do cancel. I'm going to simplify here. Let's leave the 2's for now. We can cancel them in a minute. And I have 4x plus 2x is 6x divided by 2 is 3x. So I have sine of 3x. 4x minus 2x is 2x divided by 2 is x. So sine of x. In the denominator, I got 4x minus 2x is 2x divided by 2. That's sine of x. And over here, I have 4x plus 2x is 6x divided by 2. That's cosine of 3x. I continue on. My 2's cancel. And my sine of x's cancel, so I have negative. The 2's cancel, so I have negative sine of 3x over cosine of 3x. Okay, that tells me I have negative tangent of 3x. Now all we did here, okay, is combine like terms and simplify. In this step we cancel common factors, and here I use the quotient property. Now notice, I would say this is the end of proof, but I've got a sign issue. Okay, I have yet to determine what our sign issue is. I see what it is. Do you see what my error is? Now the question is, should I redo this problem or just show you we all make mistakes and leave it? Bonus points for finding my error. I do see what it is. And I'm a bit relieved. I'm going to go back over this in red and show you my error. In the numerator, we're fine. Okay? So when I did cosine of 4x minus cosine of 2x, I have 4x plus 2x over 2 and 4x minus 2x over 2. The denominator is where I went wrong. Look, your first angle is 2x. Your second angle is 4x. So right here, this should have been 2x minus 4x over 2, which when that's simplified, that's 2x, and a minus 4x is a negative 2x over 2, which is a negative x. Okay? Here, this is okay. I mean, it should still be 2x plus 4x over 2, which is 6x over 2, which gives me 3x. Alright, now, here's the thing. I can't cancel sine of negative x and sine of positive x. So I have to squeeze a line in here. So this is like line 1, 2, 3.5, right here, line 3.5. The 2's do cancel. The negative is still in front. Okay, I have sine of 3x, sine of x, over. Now, sine of negative x, sine is an odd function, which means the negative comes out. Okay, so that's negative sine of x cosine of 3x. You with me? So, what did I use? I used the odd function, because sine is odd to handle this negative, so it just came out front. Now I can cancel my sine of x, my sine of x. The two negatives also cancel, so that means that this is not negative here, nor is it negative here, which gives me tangent of 3x. Again, I apologize. That's what you get for not paying attention to what you're doing. But my error came in as I just jumped in and assumed that was 4x and that was 2x, and that's not it at all. The order that those are in matters. So don't do like me. Pay attention. Okay, end of proof. We got that one done. This is our last problem. So this is probably the only section we've done so far where part 1 is the only part of the video, although it's going to be a little bit long, but only part 1, so don't look for a part 2. There won't be a part 2. We will finish it up. Now, I want to start with the more complicated side. Kind of hard to decide which is the more complicated side. I can tell you that we don't have any like product to sum formulas for tangent and cotangent, so I'm going to start with the left-hand side and just attempt to do a sum to product on both of these. And maybe I'll get the formula right this time. So I'm going to say the left-hand side is equal to, I'm just going to rewrite it like I'm supposed to, sine of x plus sine of y divided by sine of x minus the sine of y. Now, I'm going to look up my formulas. So sine of x plus sine of y. So I've got a sine and it's addition. Okay? If I highlight that, bring a brand new color, how about orange? A sine and it's addition. So I'm using the orange one. So notice it's 2, sine of them added divided by 2, cosine of them subtracted divided by 2. Okay, added in sine divided by 2, then cosine subtracted divided by 2. So it's going to be 2 sine of them added x plus y divided by 2 times the cosine of them subtracted x minus y divided by 2. Being real careful this time, the order matters. Okay, x had to be first and then y right here. Okay, all over. Now I'm going to look up sine minus sine. Okay, so back to my formula list. Sine minus sine is in the pink or the purple. So that's 2 sine of subtracted divided by 2, cosine of added divided by 2. So it's kind of the opposite of what we just did. Again, sine minus sine is 2 sine of subtracted divided by 2, cosine of added divided by 2. So that's x minus y over 2 times cosine of them added x plus y over 2. Okay. Now, the 2's cancel. I think everybody's comfortable with that. By the way, we've got to write a description for this. This was sum to product. Used twice. Used for the numerator and the denominator. Okay. I keep going. Cancel. So I'm going to write that over here. We're getting rid of those 2's. I'm also going to change the order. Check it out. What's inside your angle matters. Okay, this is x plus y over 2, and this one's x plus y over 2. So I'm going to line those up. So I'm going to say sine of x plus y over 2 over his friend cosine of x plus y over 2. When it's exactly the same angle inside, we can do something with it. Here I've got cosine of x minus y over 2 divided by sine of x minus y over 2. Again, the angle inside matches, so these guys pair together well, and these guys pair together well. Notice what I did. I canceled the 2's. The order in the numerator stayed the same. The order in the denominator switched. When you change the order, remember what that's called? That's the commutative property. And since we were multiplying, that's of multiplication. There are 2 different commutative properties. One's for multiplication, one's for addition. They're real clear which one's which. I don't think you have trouble with that. Now, how are we doing? Well, we're there, right? Since this is x plus y over 2, this is x plus y over 2, and we have sine over cosine, y'all know that is tangent of x plus y over 2. Once again, we have x minus y over 2, x minus y over 2, but this time we have cosine in the numerator and sine in the denominator, which gives us cotangent of x minus y over 2. You check to see where you're going, and that's exactly where you're supposed to be going. What property is that? Make sure you know these properties. That is quotient. End of proof. Yay! Done with this section. It's short and sweet. Just make sure you do a few of them so you know what you're doing, okay?